So we go through array sequential search and the binary search. And apparently binary search, as you can see from the previous example, can run much faster. And the reason it can run much faster is because it's running against a sorted array. So there's a certain characteristics that we can utilize. That being said, a natural question comes up is, how do I sort an array? Because usually when arrays comes in, they are not sorted, and you need to take the effort to sort it out. So sorting is a very important algorithm, and there are many of them, many enhancement, many basic sorting, and many enhanced sorting. The sorting algorithm we are going to introduce here is called selection sort. Selection sort is called selection sort because it selects the smallest every time. We are assuming our sorting is always ascending, which means it becomes bigger and bigger as the race goes up. So in the selection sort, we will pick the smallest first, place it in the first element. Then we will sort the rest and find the second smallest and place it in the second position. So this is why it is called selection sort. We select, and this process continues until all the elements have been placed in the proper order. Let me show you as an example. And we have this a random array. So we are going to go over the array one by one. So first pass, in our first pass, we will find the smallest and place it to 0, right? Apparently. So what will we do? We will have it's the same as what we did for running minimum, right? Running minimum will equals to the first element. Then for 1, 2, for 1 to length minus length minus 1, we're going to compare if running minimum is actually greater than array I, which means array I is the smallest. Then we will remember this I. This is the smallest. And we will also set the running minimum as array I, right? And finally, we will find the minimum. And this is actually, once we find the minimum, then we will exchange this minimum, this I, and array 0. Then we will exchange array I, 0, and array I. So this is the first pass. After the first pass, the smallest will goes to 0. So what's happening here right now? For this one, starting with running minimum equals to 12. Then for 1, running minimum, we see that running minimum is greater than array 1. So we will change this to 5. And the minimum index is 1, pointing to this side. Then 5 is less than 6. So we go to the next one. 5 is less than 19. So we go to the next one. 5 is greater than 4. So running minimum equals to 4, and I equals to 4. 4 happens to be the index of this 4. So once we go through this process, we are going to exchange array 0 and array I, which means it becomes array I goes to here, and the 4 comes here. Now, after this sorting, you can see that the first one is already less than all the rest. So first one is stable now. We need to handle the next few ones. So the second pass will be find the second smallest and place it to 1. And we are actually sorting this one now. And it happens that this one is the smallest, so it will give us, oops, a running minimum equals to 5, I equals to 1, and we just keep on comparing. Turn out there's no change. So second pass is safe. 5 is the second minimum. Then we will do this. And third pass, which will bring us here. And in the fourth pass, these two will exchange. So this is how it works. And let's bring up the selection sort method class, selection sort demo. And it's all, as always, the main has a value defined, and then it will run the selection sort method. And selection sort will start from the first element. And here you are defining the minimum values index and the minimum value itself, and comparing the first element to the rest of the array. If the rest of the array element is less than minimum value, then we will reset the minimum value and the minimum index. Once we go through all the rest of the array, we already know which element is the smallest. Then we will exchange this minimum index with the current starting position. So once we are done with this, the starting position becomes the nth smallest. The rest of the array is ready for the next step, next iteration of scanning.